Hey, Evan Reese here. The AI explosion has permeated pretty much every digital sector, and 3D modeling is no exception. There's a lot of companies that are either adding tools to their tool set or just springing up out of the ground that are using AI to generate 3D models. And one of the prominent ways that that's being done is with a workflow of text to CAD, in the same way that you might do text to image generation. And it's a really interesting way to go, and some of the results people are getting are very impressive. But they do tend to focus on mesh models that are useful for things like video game design or maybe 3D printed knickknacks, and less so on mechanical models. And there's a reason for that. The only job that a mesh model or a game asset has is that it looks cool. And they do. They look pretty cool. I'm sure that a professional 3D artist could point out a lot of the ways in which AI is producing slop in those models, in the same way that you've seen images created that just don't look quite right. But they're getting better, and they're getting better fast. Where I am curious is if we can get AI to generate useful manufacturing data. And that's a much taller order because it has to consider so many constraints. There are business constraints, there's costing limitations, there's design for manufacturing and assembly, there are strength requirements, there are mechanical functional requirements, there's ergonomics. And of course, on top of all that, yeah, it still has to look really cool. And that's a much trickier proposition. So tricky, in fact, that I was in a conversation with Caden Armstrong from SmartBench Software. And we were really questioning the premise, like, can it actually be useful, or is it only going to ever put out stuff that you essentially have to redo anyway because it's less work than trying to get the AI to consider all of those things? Right now, there's not a AI that's mature enough that we could test that. But Caden had a brilliant idea of just skipping the AI and will be the AI instead, so that we can simulate a much more advanced AI that has manufacturing experience and can consider broader context and consider semantics a little bit better than current models. And that would help us evaluate whether text-to-CAD will ever be a viable tool. So yeah, of course, I was all in on that. So what follows is our first experiment in taking turns, giving each other prompts, and doing CAD models in Onshape to pretend to be AIs. And it led to some really interesting discussions and some kind of unexpected conclusions. So grab your popcorn and settle in and just, go with us on this journey of exploring the possible future of AI and 3D modeling. All right, I am going to go ahead and be the first AI. So Caden, I am your CAD servant. What do you need?
I need a button. The button is going to be 18 millimeters in diameter. In the center, there are 4 holes, each with a diameter of 2 millimeters and are spaced 1.5 millimeters apart. At the top of the button is the word denim engraved in the surface. The button has a concave curve to it, and the surface is matched on the other side.
Oh boy. Okay. All
It's a
right.
simple part.
I'm gonna, I guess, stream of consciousness about this because there's a lot of ways I already could interpret this. And this assumes I already have like pretty good semantic understanding. So a button, at first I was picturing like a button for an electronic device or like a, off the shelf big red button. But
Mhm.
now we're reading about this. There's 4 holes. This is a button for a shirt. So a CAD an AI needs to have some semantic understanding to even interpret that. So I'm going to start with a button, and this sounds like it's concave top and bottom, and it sounds like this will work as well as a revolve. Let me just look at that prompt again. It's diameter, yeah. So I'm going to grab the arc tool with A lines. I need to leave some room on this to get that text on there. So total diameter. I'm going to change this to construction so I can do a diametrical constraint. All right, so 18 millimeters. There's no thickness, so I'm just gonna guess. Again, I'm using my like human experience of buttons to make an assumption about how thick this would have to be, but the AI probably isn't gonna know that. So I'm gonna guess that a shirt button is like 3 or 4 millimeters thick. So I'm gonna make this like 1.75, and that's the half of it. I'm gonna mirror it later, and then I want it to be tangent across the middle. So putting the center line on the right plane will do that for me. And I don't want it to get too thin in the middle either. So Yeah, actually, that's looking pretty good. So the last thing that should lock this down is giving myself however much room I need to put some text on here. Denim. What does 5 look like? Not good enough. It's too text is going to have to be small. I can change that later if I need. I'm going to revolve it. Normally I'm a proponent of mirroring objects, not sketches, but in this case, it's so simple that I think I'm just going to mirror the sketch and revolve the whole thing. Make that construction. All right, so I'm starting to get a button. Buttons have fillets, which I'm inferring is probably a good idea based on my understanding of what a button is, not because of the prompt itself. But I first need those holes. So I'm sketching on the top plane. And this is, again, simple enough that I feel like doing it in the sketch pattern is just fine. And looking at my prompt again, 4 holes, diameter of 2 millimeters, spaced apart 1.5 millimeters. These need to be horizontal, and we want this locked to the origin. And then lastly, the gap between them needs to be 1.5. That's another area, I think, of ambiguity. A lot of times when you say circles spaced apart a certain amount, it's center to center. But in this case, that would make them intersect. So I'm using some good sense to make that not the case. Shift E to extrude, through all, symmetric, remove. Okay, so we have a button. And the last thing I need is like some text. So for that, there's a couple of features, and I need to decide what one actually makes the most sense. I'm going to put an arc here, and then I'm going to make these horizontal, which will effectively make them symmetrical, like that. And then I actually want this line probably right in the middle of that. Oh, this and that, and a midpoint constraint. So now that's locked in. I'll leave that loose for now. I think surface text is what I've used, and there's another text feature out there that is pretty great, but I'm more used to this one, though I'm not going to tell you I'm like super used to it. Flip and middle, and then we need to center that text. It doesn't like it. 1 meter. Okay, yeah, we're getting somewhere now. Oh, in the surface of the button. Okay. Again, it does at the top of the button the word denim. So I I am using my common sense to know that by the top we don't mean up here. We mean on the top on the front. And it says engraved. So I'm going to cut out. The depth is going to be 0.3 millimeters. I am actually not sure why that's failing. Oh, I grabbed as the base surface the sketch, and I think it needs to be the part because that's how it's inferring what part we're working with, which is probably not how I would have done it, but it's not the worst either. It works. And then let's see, to make that pop a little more, I'm going to go bold because it's such small text. I'm gonna leave this alone. I'm gonna stop messing with the typeface. Sorry, industrial designer reporting in. Eh, Do I like it? It's it is the prompt. I think it meets the prompt. And I am also going to fill it these because I don't want to wear out the thread and make it break. Even though that wasn't part of the prompt, I'm using some common sense here as an AI that has some common sense. What that looks like. So because of that fillet on the outside, the text looks off center even though it is actually centered up and down. I'm overkill here, I think, but I'm just gonna eyeball it. I'm not gonna dimension it for now, just so we can be done. Okay, Caden, reporting back. Do you have the button that you requested?
So I'm gonna have to send you an image of it, but I do have the button. And while you have made a button, you have not made this button. And it's kind of fascinating because I don't think you made a wrong choice. And it really shows both the gaps in what I needed to describe and how things could be interpreted. So the first issue that I see is actually on the back side of the button. You have concave on both sides. And what I was trying to imply was that it's concave on the front and convex on the back. The
Oh,
curvature matches on
let
both
me see
sides.
here.
And that's
Mm,
it
matched on
makes
the
sense
other
because
side.
many
Yeah.
buttons are what you have. The other thing is that you've taken inspiration from other buttons that you've seen. So you have this kind of like border area where the denim word is. This button is actually one continuous surface. There is no like edge to it. It's the concavity is the entire face.
Mm,
You chose the thickness. I forgot to give you a thickness because that wasn't something I was thinking about. And I think you chose 3 millimeters measuring the actual button. It comes out at 2. So close. You made
all
a
right. I
design
never
choice.
said that I was a button expert.
That's fine. This is a fairly thin button, I would say. But the interesting thing is that you put these fillets into the holes, the actual button, straight holes.
Are you holding
It's
it
just,
because it broke off of one of your pieces of clothing?
no, it's like the
Okay.
spare button that came with some piece of clothing that I bought, but I don't know
Yeah.
which one because it's been sitting next to like the front door keys. So
Hmm. Well, yeah, I don't know.
yeah,
I feel like the little details like that are something that comes with design experience and like thinking about thinking about that stuff deeply, where I don't know what it would take for an AI to be like, those sharp edges make a stress riser so that when someone pulls on the button, it's gonna like cut the string. So let's fillet that. Like I don't know how to get an AI to think like that.
yeah. Well, and like you made the choice of making denim bold font because you were afraid that it wasn't going to be readable. Your font's way bigger than it is on the actual button. Like on the actual button, it's quite a thin font. But you did get the positioning almost exact. Like I think if you didn't have the flat border, it would almost be exact to what the button was,
Cool.
which is kind of impressive.
Kind of guess too, though.
Yeah. Hole placement as well. I think you nailed it based on my ability to measure this button. 100% accurate.
Cool.
So yeah, it's definitely fascinating. It's a test in both my ability to describe what I want and doing it in a way that isn't ambiguous.
It feels like where it really gets handy is not in like describing every feature in the feature tree or like saying like every fillet is this size and this exact edge at coordinate, whatever. Like that is not practical. But as CAD gets better and better, semantic understanding and then can have references of other buttons that it's seen, it's gonna be able to make a workable one. It's going to be, I would say, unlikely that you're going to be holding a button and then it's going to produce that exact thing without help from images.
Yes. Well, and I guess the question is like, why am I doing this? If I want something that's absolutely perfect, is this the right tool for it? You've made a functional button. Is that good enough? Whereas the other question is like iteration. After I've told you what is wrong about this button, theoretically you should be able to say, okay, well, this border area, I didn't want that. Could you just make the surface extend to it? And you could iterate, right? Like design in CAD is an iterative process. Uh, you can't expect to get it correct first time, even with an AI.
Yeah.
So
All
very
right.
interesting.
Now, I think you had mentioned one other prompt, this one being like the simpler of the two. You want to try that now?
So this is a toothbrush holder that I have actually built. So I'm not going to show it to you because we're working off a text
Okay.
prompt, and hopefully I can describe my own creation. So this toothbrush holder is a freestanding toothbrush holder for both toothbrush and toothpaste. The base is 75 millimeters wide, or sorry, 75 millimeters deep,
I'm going to listen to the full
150
thing and then
millimeters
I'll
wide.
start cranking. All right.
The
So
material is
75
20
millimeters.
millimeters thick.
Sorry, I was talking over you. So
Yeah.
75 millimeters by what now?
75 by 150, and it's 20 millimeters thick.
Okay.
The front edge of the base has a bit of a draft to it, just a slight draft angle. The back of the toothbrush holder is 100 millimeters tall. It's the same width as the base and the same thickness. The back piece has thin kerf cuts that are 5 millimeters wide and 5 millimeters apart that go 75% through the thickness of the back piece.
Okay. I'm going to have to
Similar
read that
feature
one.
on the front, except instead of the lines being horizontal, they're vertical.
Oh. Okay. And they're going more than halfway through. So we're going to make a hole. We're going to make holes.
Yeah.
Okay.
The top piece is a mirror of the base, except it has two holes on the right side, toothbrushes, and one large oval hole for the toothpaste. The toothbrush holes are 20 millimeters in diameter and 20 millimeters apart. The toothpaste hole is 20 millimeters by 60 with full round edges.
Okay. I think I'm picturing it, and I have your text prompt that I can go actually read for some of that. But before I start, I'm curious to know what went into this design for you already. Like you already obviously had a toothbrush and toothpaste in mind. So to know that you want your holes to be 20 millimeters, like how did you find that out?
I took a tape measure to my toothbrush and kind of eyeballed it.
Yeah.
Uh,
Okay.
Same with the toothpaste hole. I took a tube of toothpaste and how big was it, and I kind of just guesstimated.
Okay.
Um, and then the rest of the decisions are all the same kind of thing. I look at a ruler and I'm kind of estimating how big I want it to be.
Yeah. Okay. Well, I think I'm going to go ahead and start modeling this. And I have some decisions to go ahead and make. First, I could sketch the footprint and extrude it up. But because it sounds like it's going to be, like a top, a back, and a bottom, that I might just go ahead and sketch it all on the right plane. And if I recall, it was going to be 75 millimeters. I'll go back and double check these in a second. 20 millimeters thick.
An AI would
And
perfectly know this information.
yeah, it would not forget. It would not forget. And I believe the thickness was all the same on these. So I'm going to use equal constraint for that. And I will go review the prompt. Prompt two. The back is 100 millimeters tall. The top piece is also 20. And I interpret that to mean that the back piece itself is 100 and that the additional height is coming from the thickness of both of these. And there we go. There is a custom feature called extrude separate that would actually be fairly appropriate here, but I'm just gonna do it this way. And 100 millimeters, not 100 meters. That might be too big for your bathroom. Oh my god, I did it again. Okay, shift enter to make another one. Symmetric, 100 millimeters, and new. Here's symmetric, new. Okay, so I have this. I'm gonna name that top. Uh, Shift N is what I'm using here as a hotkey to rename those. Okay. All right. Something's feeling 150. Okay. Got it. All right. This is another thing that, probably an AI wouldn't necessarily know to do, but I love the idea of it kind of knowing what dimensions would be valuable or maybe changed or you could prompt it because then now I've just set it as a variable here and I can change the width of all of these except for I somehow messed up that first one.
I think if I was making an AI, I would have it lean towards making more variable features,
Mm-hmm.
simply because it kind of like you're giving dimension, like the explicit dimensions, and
Yeah.
that's honestly that's how I model. Is I sit down and I measure something, I put all the measurements into my parts view, and then I work from there.
Yeah, yeah, totally. I mean, it's more similar to code, and like the more that I do CAD and code, the more I realize that CAD is code. Like this is kind of a very abstracted like IDE in a way. Like we're building code that makes this model. We're not just building a model. I don't know if that's too esoteric, but okay. Draft on the front face doesn't really specify how much draft. Let's see. Slight draft. Slight draft. That feels slight enough to be noticeable. And I think I remember the top is mirrored. Top is a mirror to the base. So that means it has the inverse draft. And because these are the same, I'm going to make a variable. Not draw, draft. Here, that, draft. Cool. Lots of other ways I could have done that. I suppose I could have just done it and then done a mirror across like a mate connector here or something else, but we're here. Okay, looking back at the prompt, let's tackle this curve. So 5 millimeters, 5 millimeter groove and a 5 millimeter gap. And let's see, on the front of the piece, they're vertical, and on the back, they're horizontal. This is actually a great use case for my grid extrude custom feature.
Fancy.
So I can just click a face, and instead of extruding like that whole rectangle, I can specify what I want, and we can do rectangles, and I can make the rectangle taller than this whole thing. I'm going to change it to remove. The depth is about 75% of 20.
15 for quick math.
And even that one is I'm going to make a variable. Okay, and now I'll just go ahead and do this as our merge scope. The cell width needs to be 5 millimeters, and the cell gap is also 5 millimeters. So there's our front kerf, and just going to go ahead and variabilize that as well, making up words here. All right, Onshape, if you're listening, I want to copy and paste this feature and just put it on the back and change a few things, but now I have to rebuild it. So I hope that you will do something like that for me. That would be delightful. Okay, here we go.
My Renaissance tool has a duplicate feature option in it.
Oh, that's right. Yeah, I did see that, and that is so good. Love that. Curve. Merge scope again. And here we go. Curve gap. I love how the autocomplete works because I can just type KG and it knows curve gap because it's like actually looking at what I wrote here. And then the cell length I need to make, I'm just going to make it 200 because I know that's bigger. Or I can make it equal to the width times 2 or something that'll just always be bigger than this. All right, so that is great. We've made a really neat lattice by just cutting this way and cutting that way, and we're getting holes through. So love that. All right, and I don't think there's any information about how these are joined, so I'm just going to assume that it's magic. And let's see, 2 holes on the right side for toothbrush and a large oval for toothpaste. Full round ends. Okay, great. That's one sketch. I'm just going to do it on the actual top plane instead of sketching on the object itself. So that's going to be 20. That's equal, and actually this can go ahead and be equal. And I'll get rid of that. Okay, this is a little awkward angle. That's better. 60 millimeters with full round ends. So I can dimension this arc to that arc. And then it's unclear from the instructions what the spacing ought to be. So I'm just going to assume that all the gaps should be equal and drop some lines in here that I can then set to equal. These all need to be horizontal to one another. And I guess I'll go ahead and make it equal to the front as well. So that's locked in. Remove. Through all. Wrong way. Not that part, this part. All right. Let me just give this a skim and see if I got it. Toothbrush and toothpaste holder. The base is 75 by 150 by 20. Front edge has some draft. The back is 100 millimeters. Same width as the base, same thickness. Curve, 75%. Yep. The top is a mirror of the base, but it has these holes. Okay. Caden, do you have your toothpaste and toothbrush holder?
I think you'd have to Boolean it all together, but yes. So we made some changes for the prompt. So I have these gaps here because it is actually joined through there. There's a lighter here, but I wasn't a big fan of that design. I wanted to make it 3 straight pieces so that theoretically it would be easier to manufacture. The joint is still unclear. But I think the interesting thing is that the base, you started with the correct dimension and you drafted outward. So this edge comes out, whereas mine drafts in. So they're slightly different. So again, that's an interpretation of, I'm saying it has a draft to it and I didn't specify
Yeah.
direction.
Actually, I think that it's probably safe to argue that it should have from that prompt drafted in because, I can see here that this actually no longer meets the spec of the prompt.
Yeah.
So yeah.
But again, is that something that is clear? Like maybe there is a scenario where the other interpretation's also valid. The I think the lattice you nailed. I think the holes and everything, like that's if that's the one thing that you got wrong, then it it pretty well. I honestly thought this was going to be a lot more challenging because it's there's different elements and it's not necessarily clear, but because you have the idea of a toothbrush holder, you know what the end result should kind of be.
Yeah. Yeah. Comes back to that semantic understanding again, like knowing what a toothbrush holder is at some archetypal level really matters. Yeah. That is
Um,
interesting to do. It was an interesting
well,
project.
and the
So
interesting thing is
did the
that you,
height work out? Because I made
oh
the
yeah,
back, I think I made it tall, overly tall by the thickness of each of the top and bottom.
yeah. So I measured the literal height of the piece, but in all fairness, since the design changed slightly, I think I said the back piece is 100 millimeters tall, which I think you did. So that's
Well,
a
yeah,
change on
and
my
I
end.
think maybe the word piece was like making me think about a different object, and I think an AI might have
Yeah.
had the same feeling. So it's like the back piece, the front piece, the bottom piece. It was like three
I
pieces.
mean,
Got
it is three pieces. This is
it.
three
Yeah,
separate pieces put
true.
together. So, but you asked an interesting question halfway through is like, what's the joint between these two? And that's something that like I've come up with a design, but I don't have a way to join them together. And that isn't in the design. So like while we have a nice design, it's not
Hmm.
manufacturable, right? It still needs that level of knowing, okay, how do I join this together?
Right. It,
Realistically, gluing that joint would be difficult to do cleanly.
yeah.
And from a design standpoint, I also know that this bottom face should not meet the curve. Toothpaste gets caught in there and you can't clean it.
Yeah. I
Yeah.
think
So those are,
another piece here is like both of the things that we've done so far. You know exactly what you want. You have a super clear design intent because you're referencing an existing thing. But for this to be useful to designers and engineers, text to CAD needs to be able to fill in gaps where you actually don't even have clarity yourself. And I am not sure exactly how to get there. I mean, a lot of the text to images will give you like four options. You'd be like, do you like any of these? And I feel like that text to CAD is going to have to do something similar, or maybe even leverage the like parametric nature of the model to create variations and like walk
yeah.
you through the options for those.
This is a design where I think I would actually really appreciate having options. My original vision was actually, I wanted to make it wavy. I wanted waves on the back of this and I was going to CNC them so that it was a nice texture. It was very difficult to model and it was going to be difficult to manufacture. And that's part of the reason I went with the straight lines. But giving a variety of, make it wavy is
Hmm.
interesting because that's very open to interpretation. Is it the shape of the gap that's wavy? Is it the that front surface? Is it undulating?
Right. Do we mean linear waves or like circular ripples? We don't know.
Are they all even? Are they unequally
Yeah.
spaced? There's a lot of opportunity there to kind of play with the idea, and it's something where exactness doesn't matter, and having a variety of options does. I think, honestly, this went better than expected. I was expecting text to CAD to be a nightmare, and maybe it's just we've really shown just the best case scenario. I don't hate this process.
Yeah, not the worst. Let's reverse roles and we'll try one with a sketch as part of the prompt.
Yes. So you have given me this sketch and a prompt to go along with it so that I have some dimensions. So 3D print optimized bracket like the sketch below. Holes are a quarter 20 clearance fit. It should be 75 millimeters deep, 75 millimeters wide, and 100 millimeters tall, and 15 millimeters thick. So the interpretation is this thickness here is going to be 15 millimeters. Make it easy to adjust the depth, width, height, thickness of the bracket for alternate design. So right away, that's telling me I need to make variables. So let's start there. Yeah, right, Part Studio. So we're going to have a width. That was
I'm gonna follow along with you in Onshape, which is a really cool functionality, by the way. Cloud CAD for the win on that.
deep and 100 tall. We're going to learn how bad a programmer is at doing CAD.
Yeah, it's like you know the system beneath the hood better than most people by a lot.
Well, it's funny. I learned Onshape by doing feature script first.
Yeah.
I had to learn how to use Onshape as I used it through feature script.
Yeah.
And it really frustrates me when you find out that certain options are only in feature script. Setting an arbitrary plane. Planes are a difficulty for me, and it's super easy in feature script.
Yeah. Yeah.
Holes are a quarter 20. So I think my idea is I'm gonna just do this Z shape as a sketch, extrude it, and then add the rib as a. I guess I can do the rib at the same time.
Yeah. And as you're sketching that out, I wanted to say I did write this prompt again, assuming some level of understanding, like what does 3D print optimized mean? And right now with text to CAD, I don't think we're getting that, but it's still early days.
In all fairness, I don't know how I would optimize this for 3D print. I would probably put it on its side, but do I need to design it? Oh, you got holes. Yeah, see, this is
Yeah.
the challenge is that even me as a person who's 3D printed and failed, I know if you put a hole sideways, then you have overhang. But we also have this overhang as well. So we've overhanged in two directions, or potentially three with the rib. Um, so that's a challenge. I'm curious if an AI with more experience would be better at that.
Yeah, it is a challenge, and honestly, even myself looking at it, when I did the sketch, I really wasn't thinking too hard about it, which is the way that a lot of these prompts are going to go. Is like we're asking AI to like make this, but for injection molding, and it's like not always that simple. And looking at that sketch, like my gears are turning, and I can think of like three different approaches that would all probably work and have pros and cons for optimizing for 3D printing. But yeah, to have an AI think those through and then choose the right one is it takes a lot of experience and understanding. Not impossible though, but I just think we're not there yet with text to CAD. And another thing that's interesting is the idea that actually maybe the AI might know more about that in the future than a designer, and instead of producing the CAD or in addition to producing the CAD can provide DFM feedback. I think that is a really interesting use case for AI.
It's something I struggle with 3D printing is knowing where I'm going to have problems. Things like not enough base plate or adhesion. So like knowing I'll have to put a brim and where it needs to be supported and what maybe doesn't need to be supported. It definitely takes me a couple tries to like I will design something, go into my slicer, it complains to me, and then I have to go back and rethink the design. And that's experience I just don't have.
Right. Yeah. Well, I know a lot of the print companies will have you like rate your print or how'd it go, kind of thing after every single print. And if they're aggregating that data, they're going to have a really great data set for training.
Yeah. Okay. Starting off, be
Yeah, this is looking right.
over two, and then it's symmetric. And I'm going to assume this thickness matches. Starting off, so, all right. There's my rib.
Hey, there it is.
Let's do ovals. Fillets first, and then maybe I'll do fillets and then use them to dimension them. AI is going to have to get really good at eyeballing things.
Yeah. Yeah, I don't think I prompted the whole spacing.
There's no hole spacing. There's no fillet dimensions either.
Yeah, exactly.
This edge needs to be filleted. It looks right in some areas and wrong in others. See if concentric to there will produce holes that are correct. Quarter 20 is just quarter-inch hole width, right?
It's I always use the whole
Oh,
feature because there's a whole
clearance.
like
There we go. Yeah,
yeah,
one
there's
of
a
them.
whole thing
Clearance
to
hole.
it.
All right. And then same thing on the bottom. Think I'm done.
Yeah,
Yeah.
you've
The,
done it
inter-
by Jove.
the interesting thing is like you look at the drawing and there's design that's saying, okay, like fillet all of these bit, but then the backside has no fillets. And it's like, is that intentional? Should I add fill there? Like how much liberty do I take?
Yeah.
It's like, why is the top filleted but not the bottom?
Yeah. Yeah, I imagine to make image to CAD or like, adding images, there's a lot of times where you can like adjust the weight. Sorry, I bumped the mic. You can adjust the weight, like how much weight it carries, like do exactly the image, or you could be like, just kind of like think about the image a little bit while you do your model. There's like a
Yeah.
whole range.
The the interesting thing is your holes are much larger in your sketch than they actually are.
Mm,
A quarter 20 hole is only 6.5 millimeters. So relative to a 75 millimeter width, kind of interesting that it's definitely has to take it as a suggestion that it's like this hole must be this dimension because otherwise that hole would be massive.
yeah,
Um,
yeah. I think it has to take liberties. Otherwise, we wouldn't need to do CAD. We'd just do sketches and they would be right, but that's not
yeah.
realistic.
But and then like I think this is a very simple design, but in this workflow, I'd love to be able to have more interactivity where you can kind of like highlight an area to say this, because that's something I think I struggle with when doing. We've thought about this text to CAD idea, and
Yeah.
the issue that comes up, and this comes up in feature script. When you write code that builds a model, the biggest challenge is how do you point at something and say, I want to fill it this edge?
Yeah.
What makes it that edge? And in feature script, you get really good at generating queries. You can describe that. And the challenge then to a person is like, how do I describe that? You're using things like front, top, left, and right. But, if we look at our other example, I was saying the right of something, but really it was the right side of the top plane. And being
Uh-huh.
able to kind of just circle your mouth with something and say this bit would be really valuable in this kind of AI engineering type workflow just
Yeah.
to remove ambiguity. Um, because ultimately a lot of it is very visual. I want to point and say this.
Yeah, very much agree. I think right now text to CAD is kind of like a one shot thing, and you can't be like, do what you did last time, but tweak it. But, for like your toothbrush holder, it would be great to just start basic. Be like, I want to make a thing that's this exact size. And then later you go and click on the back face and say, do this curve here and do this curve there. And create this like feedback loop with the AI and it's more conversational. I see a lot more potential with something like that.
I mean, when we reviewed the design, like we looked at this bottom and I realized, oh, that we shouldn't put kerf there because of this reason. And like, we can look at this design and go, okay, now that I have it, I can make decisions. Like realistically, that kerf should, like 1 inch up from the bottom, there should be no kerf because when I go to manufacture it, I'm going to put dowels there, right?
Hmm.
So it solves the problem of cleanliness, but it also gives me manufacturability. And that's something that it's like maybe it wasn't there in the first prompt, but being able to highlight that section, say, okay, remove it from here would
Yeah.
be more valuable than having to redo my whole prompt.
Yeah.
Um,
Yeah. Yeah. For sure. There needs to be like the idea of like rough draft to like first edit to like final details. You have to like prompt each one separately.
and again, that it still makes me wonder, in a complex design, like we're dealing with very, very basics here. If you look at complex engineering, how much of a book do you need to write to get there? And, how much of a mix is it going to be? If you have AI that just spits out step file, that's not going to be helpful because,
Yeah.
maybe those last steps are you have to come in and do it manually. And it's just an aid in starting. Um, that's really the question that I'm not going to have an answer to. Like to sit down and do this exercise with something that takes hundreds of hours to engineer is, you know, challenge.
Yeah. Yeah. I think we agree that AI is inevitably coming to CAD in some form and it's going to help in some way. But what's unclear is exactly what that is going to look like and whether text to CAD is going to be a major part of it or not. I think I could see value for something that's like text to CAD when it's creating a model that is hard to model and is complex, but is in a well established sort of format. Like if you're like, I want a planetary gearbox and it needs to have this ratio and fit in this specific envelope, like that's documented enough for an AI to go and do. And that's a lot of manual work otherwise. Like something like that could make a lot of sense. But for new to the universe products, trying to describe something that maybe you just have in your head or maybe you have a sketch of or something, I'm unclear how useful it'll be. But yeah, for things where it's like sort of established, like if you wanted to make a Raspberry Pi enclosure that's
Yeah.
pretty basic, I think AI can probably handle that. But other areas I think would be kind of as like we were describing, like having this kind of conversation with your CAD model. I think that's interesting to have the AI as like a an agent in your model. So even if like I could see it refactoring a bad model, like or like a
Yeah.
an unstable model. It's like okay, I've got this model. This is what I want. Now just go remodel this for me, but make it good. I think that could be powerful because then you can incur a lot of technical debt and not have to pay the price for it, which would be sweet.
Yeah. It's we're at the point that, you look at other changes in the industry, like going to cloud. When Onshape first came out, what was it, 8, 9 years ago? It was very different from what it is today. And I think if we had tried to evaluate, future of cloud engineering off of that, we would have had a very different picture to what it currently is.
Yeah, yeah, true.
And it's probably the same here. There's always something that's going to come through and go away. The question is like, what's going to be around to stay? Like AI code, there's a lot of talk around that right now.
Hmm.
And the even if you don't use it, you're still benefiting from it sometimes. When I write code for Onshape integrations, I'm using Visual Studio, and while I don't generate code with AI, the predictive text has gotten so much better in the last year or two. Like the ability for it to just kind of do the very, very, very small menial tasks has seen huge improvement for me. And I could see even just that it's, we're not doing a full model. It just knows that you need that extra feature copy, right? You made the complaint as you were modeling. You're like, I wish I could just duplicate this feature and do the other side.
Yeah.
That is exactly something that like predictive text for CAD. And maybe that's the future.
Yeah,
It's
which just let's just plug Renaissance again on that. So, Caden's plugin can copy and paste features. I haven't played with it yet, but I've wanted that functionality for years. So
I haven't actually tested on custom features like that
nice.
before you
Okay, yeah,
plug it. Does it actually
we'll have to
work?
give it a go. But yeah, no, I love the idea of that functionality. Anyway, all right, back on track. But yeah, check out Renaissance. Yeah. So what else? What else do you imagine AI might be actually better suited for than generating CAD models from scratch, but it's still related to CAD?
I mean, the big one that comes up is anything that's extremely labor intensive and repetitive, right? Being able to
I
train
think I know where you're going with this.
it's drawings, it's bills of
Yeah.
materials, it's metadata, right? It's a much simpler challenge and it has a huge impact. The value
Yeah.
of just moving data from one system to another is massive. And there are companies out there that are doing AI drawings, AI for MRP, AI for ERP.
Hmm.
There's a trickle in every industry. Even Onshape has AI, right? Like the
Right.
AI for documentation solves that challenge of having to sift through documentation. The information's there. It's just making it more accessible. It's it's gradual
Yeah.
though.
Yeah, I agree. Drawings is a big one that comes to mind for me, and I feel like I've seen the company you're talking about. Remind me what it was called. I don't remember the name. Draft.
Drifter.
Yeah, something like that. Looked really awesome. I mean, making drawings is like I think drawings are going to be around, but making drawings hopefully will become obsolete. Like I think drawings are going to be needed, but we may not need to make them all until some future when drawings are made by AI and read by AI. Then maybe we can just get rid of them altogether. But
I mean, I've seen that there's a company doing AI drawings and a company doing AI drawings to CAD. It's
yeah,
the cycle exists. But you kind of answer questions like, why do drawings still exist? Like, if I can share a document in Onshape with someone that has all of the information that they need and has every critical dimension, why do we
yeah,
still send a PDF? Maybe
yeah, totally. Yeah,
that's
right.
the question you'd be answering.
Right now, drawings capture metadata that's not like part of the model, like the material and the critical dimensions and whether it's plus minus or just plus. Like those kinds of things, or like inspection areas, but that doesn't have to be in a 2D format. And I'm excited
Yeah.
for a future in which it's not.
I mean, that's the future's model-based definition.
Right on. Yeah. All right. Well, I think the experiment was a success. Actually, it was smoother than I expected it to be.
Yeah, I went in with a very pessimistic attitude, and I came out going, okay, maybe this isn't so bad. I can see value.
Yeah. And it feels like it's a piece of a larger AI tool, right? Like that it's kind of how our actual brains work. We have all these little like subsystems that are kind of competing to decide what we actually do, and I think AI is going to end up doing that. Where we have the text to AI model, but then there's also one that's tied into a company's like business logic, or they know like big picture objectives. They know that it can maybe look at a model and infer like, oh, it might cost this much if it's made this way, and you can start to get all of these AIs kind of like jostling together to then make decisions, and that's where it gets more interesting to me. But just text to CAD probably lacks the required context as a standalone thing for a lot of the things I'd want to use it for.
The challenge with, and like I'm seeing this in the software world, is there's a level of responsibility to what you're doing. You can use an AI tool right now to make a website and push it out to the world.
Yeah.
But then you're also seeing these downfalls where, API keys are on the front end and there's no authentication done correctly, and it's a massive security risk.
Yeah.
And the CAD equivalent to that is I have an AI build a part for me and I go, that's great. I send it off to my manufacturer who starts making tooling based off of it, and
Oh man.
surprise, it doesn't work. You know,
Yeah.
injection
So,
molding is incredibly difficult to do because there's so much knowledge that maybe isn't captured out there and an AI won't have.
mm,
And, you know, understanding that level of responsibility of what can I do, what can't it do is forever going to be the new kind of challenge with the tool.
yeah.
Um,
Yeah, and
we,
you hit on something. Like it's scary to have the idea that somebody's going to make a CAD model that is they don't understand the model and they don't understand the design, like vibe CADing or
yeah,
whatever. And then, is that even useful? Like if no one actually understands what it is that you are making, even if it worked, let's say you actually manufacture it and it works, like that's still scary.
yes. It's the same analogy as like when you were a child learning math in school and you punch the numbers in your calculator and you go, it's 20. And then you get to physics class and you learn, okay, 21 units now matter. You have to add that layer of thinking to it.
Hmm.
It's very easy to kind of rely on the tool and just assume the next. And yeah, I don't think that level of responsibility will ever go away.
Yeah, yeah. Well, man, this has been super fun. Thank you so much. Doing this video was Caden's idea, and he pinged me about it, and I loved it. So I was on board. But so thanks so much, Caden, for coming up with the idea and bringing this to me, and just reaching out in the first place.
Thanks for participating. This wasn't a one-person job, but a lot of fun.
So that actually went better than either of us expected that it would. The results were closer to the prompt than I thought they would be, and I think that it probably at least passes the test of being better than starting from absolute scratch on the model, probably. But I still would say that text to CAD as a standalone workflow is probably not where it's at. Maybe with the exception of areas that have really well established, highly technical approaches and are high labor. So I'm thinking of things like gearboxes and wind turbines and things like that, where the precedent is already there. The math has been done, and we just have to do a lot of mouse clicks to produce that model and a lot of niche education to make sure that standards are being followed. So AI is great at that. I would love to see AI used in that way with text to CAD. Also, another area that I think AI is going to be really well poised to help with is in 2D drawings. And there are already companies working on this, and I hope it becomes more and more mainstream. I don't think that 2D drawings are going to be going away anytime soon, even with the advent of model-based definition and the ability to put some of those design intent things into the 3D model that you normally put in the 2D model, like the tolerance requirements and things like that. I think that governments and large organizations are just going to need that 2D documentation for a long time. But that doesn't mean that humans have to make it. I think that AI is probably pretty well suited to tackle that for us and let engineers get back to doing design and engineering. Another area that I'm interested in to see AI and CAD kind of come together is in providing certain expertises. So, if I had an AI that was an expert at injection molding design, and that could be reviewing my model as I go as a kind of a CAD co-pilot, that would be really valuable, because then you can kind of make changes on the fly instead of getting feedback from your vendor later and then having to back way up and rejigger your model. Like if I could get feedback that like, oh, you need to thin that snap so it deflects properly as I'm modeling it, as I'm even doing the sketch, that would be really cool. Kind of in a similar vein, AI is really good at making pretty good guesses about things that otherwise take a lot of calculation. I mean, that's really what like image generation is all about, is AI is just making a lot of guesses about where the pixels need to go. And so it could do the same thing for finite element analysis. And it won't be as accurate as if you actually triangulate and crunch all the numbers, but all that number crunching, it takes a lot of compute, whereas AI can kind of knock it out pretty quick. And it might make it possible to have live FEA feedback on your model at all times. And then at the end, you might want to run a real computational one to make sure you're really right. But having that kind of feedback live would be really, really important. And then, of course, it can even maybe do some of the modeling in a feedback loop based on that feedback. And that's where you're getting like these generative designed things that are optimized. I think that's a powerful future workflow. Same goes for rendering. I would love to see 3D rendering using AI instead of doing all that heavily computational ray tracing. I want to feed an AI a mood board and some like style guide for my business and some text prompts and have it produce the same consistent views for an entire product line. I think that would be really fantastic. And then maybe even further into the future, I can imagine this sort of network of AIs where you have one that's an expert in costing constraints and one that does DFM and one that is your text to CAD and maybe understands CAD best practice and all of those things. And they can kind of democratically together come up with more sensible solutions than any one of them could on their own. So I'm excited about the future of AI in CAD. I think text to CAD is really just, even for the companies that are developing it, I think they understand that it's a stepping stone towards some much more empowered future. So I don't know, where do you think it's heading? Let us know in the comments, and thanks for watching.